again. The next presentation is by Arto Oksanen on observing a recurrent nova in the Andromeda galaxy, part 2. I think I remember part 1.
Okay, yeah, hello. Yes, I'm continuing my talk from the last meeting, 2019. And we start with a short recap from the last talk. This is a small cartoon of how to make a type 1a supernova. You start up with a binary star, kind of normal binary star, and then the heavier of those two stars will evolve first to the red giant phase. And if those stars are close enough together, they will form a common envelope, and the separation of those two stars gets smaller and smaller. And eventually the heavier star will end up as a white dwarf. But at some point the lighter secondary star will evolve to red giant as well, but then it can't get bigger than its Roche space, and it will start spilling its material on the white dwarf. And if the white dwarf gets enough material, 1.4 solar masses, it will explode as a type 1a supernova. It's a simplified recipe. Okay, type 1a supernova, if the white dwarfs are a bit strange objects, if you put some more material on the white dwarf, it will get hotter and smaller, and of course heavier. But it's strange that it will get smaller if you put more material. It gets more dense. But if it exceeds the critical limit of 1.4 solar masses, it will explode as a type 1a supernova. And as we all know, it's very important cosmic standard candle, those, because they all explode at the same point. It's always white dwarf with 1.4 solar masses. But in reality, it doesn't go as easily, but there are usually several nova outbursts before the supernova phase, because the material will build up on the white dwarf. There will be a kind of ocean of hydrogen on the top of the white dwarf, and if there are enough hydrogen on the white dwarf and it's hot and dense, it will start fusion on the surface of the white dwarf, and then you get a nova outburst, nova eruption, when the most of this material is ejected to the space, and the same process starts all over. Okay, then we can come to recurrent novae. They are novae that are repeating in less than 100 years. They are no different from other novas, but the recurrent or repeating time. And the shorter the nova interval is, the closer the white dwarf must be to this critical mass, because it gets shorter with heavier and hotter white dwarfs. And the fastest known recurrent nova is in Andromeda galaxy, this M31N 2008 12A. Again, you can find it on the northeast corner of the Andromeda galaxy over there. And this is a comparison chart with all observed nova eruptions And as you can see, it was found in 2008, and since then it has been erupting every year. Last year it was December 2nd. And then there is intensive monitoring ongoing to detect always the next outburst as early as possible. Because this star is so faint that you can only see it when it's in eruption. And my observing strategy is still the same as 2019. I'm trying to get one data point on every clear and dark night using my astronomy club's 40 centimeter Ritzeau-Chrétien telescope in Hankasalmi Observatory. It's a remotely controlled telescope. And I'm running a ACP script that takes automatically 25 1-minute unfiltered exposures. Then I will stack those images with Maxim DL using remote desktop on the observatory computer, and run a photometry script to get the photometry or usually upper limit of the star brightness. And then I download the co-added image and photometry file to my own computer and submit the photometry to EVS5 database and examine visually the combined co-added image and email the results to the project PI. And so far I have done over 300 imaging runs of this star. And usually what I see on my computer is this. There is, I'm using a DS9 to check this field, and I have a pre-made region file that will plot these two comparison stars on the image and the position of that nova. And usually there is nothing, it's just empty space. I started 2016, and these AVSO light curves, my observations are marked with this brown marker here. Then we made an observing run in the spring and in the fall, and it was rather good weather there in August or so. But then in December it was completely cloudy, and the nova eruption was on December 12th. And of course, right after the nova outburst, the weather got better, and I could make new negative observations. So I missed this eruption. And same happened 2017. You can see that November and December is usually very cloudy in Finland. It's bad time for observe. There was a nova eruption there, and right after that, the weather was getting better again, and I could make new negative upper limit observations. And 2018, again the same. The weather was much better, but of course, those few critical days, it was cloudy, and I couldn't see the nova. Okay, then we go to the part 2, what happened since the last meeting. 2019 we had a major renewal in the observatory. We got a new CCD camera, a new control computer, and new control room as well. And this delayed the observing season, so we got our first light on 24th of October. And here you can see the new SPIC STX 16803 CCD camera on our telescope and paramount ME mount. Okay, first observing run with the new camera was November 4th, and the same result, nothing seen there. But two days later, on 6th of November, this is the first image. I usually, when I'm running this 25 image sequence, I take images one by one to my computer and check those for focus and everything. So then also the pointing with the new computer, a new setup was a bit wrong. The star was not in the center. But on the first frame, I saw that there was something. Could it be the nova? And I sent a short notice to the PI of the monitoring program. Of course, I didn't get any reply because I had sent some negative or the false positive observations before, because easily you get some noise on the right pixels and it shows like something. Okay, then I stacked 8 frames, first 8 frames, and it was much better. You can see the focus is still a bit wrong, but there is definitely something there. And I sent a new message, 8 frames looks more promising, and I got a reply immediately. Wow, looks very promising indeed. But I waited until I got 25 images, and then it was very evident there was a nova on the screen. And I sent a new email to Matt that I sent a discovery report on our email mailing list, and started to make more runs. I didn't stop for the only one 25 image run, but I tried to make as many as possible. And it was immediately published as an astronomer's telegram that the eruption was discovered. And it was clearly detected at 17 UT and UTC, and it was magnitude 19.4 at that time. And also got a congratulation email from the long-time PI of the program, from Martin Hense, and he was quite happy that I got the nova. And here's before and after images. This is the 4th of November and 6th of November. It is about the same. And on that night, I was able to get 12 of those 25 image runs. So I got 12 data points. And the light curve, it shows the nova getting much brighter during my observations. And I think this, my first data point, is the earliest detection of any eruptions of this nova. But then the following nights were, of course, cloudy. So I got only this first night when the nova was still rising up. This is the modeled light curve, this solid line. And here is the AVSO light curve. Quite many positive observations. There was my 2 negative observations before, and the positive observations, and then the other AVSO observers observing here. And my observation triggered many professional telescopes to follow up this nova. And for example, these are Hubble Space Telescope pointings of that star. Basically 4th, 5th, 6th and 7th day after the eruption. Okay, then next year, 2020, looks quite familiar, a lot of negative observations by me, and then the nova outburst, no, not me, and negative observations after the eruption. 2021, I had a better luck, negative observations, then was many cloudy nights, and negative observations just before the nova eruption, and then many images on the first night. It's a before and after image. The eruption was November 14th, and my last negative was November 11th. This was close to the maximum, so it's much better looking on this frame. And here are the AVSO data points of the 2021 eruption. Brown ones are mine, and I think all the other green ones are from Tony's, Tony Van Munster's data. I had clouds in the middle of the night, and overall the weather was not so good. But still, I don't know why there is so big difference between my and Tony's observations. We haven't really compared why. And last year, we had technical problems. Our paramount mount was broken most of the fall, and I was able to get only 2 negative data points there, and the eruption was December 2nd, but very few observations. I don't know why. Maybe other observers had some problems as well, or bad weather or whatever. One of those data points are from Finland. There was a very small gap of clear sky on that, the other observer. Okay, when the next eruption is coming, yeah. This graph shows year as a x-axis and the day number. So it's the number of days from the beginning of the year. So you get a kind of calendar, and as you can see, it's almost exactly 1 year is the recurrency period, because each year it happens in more or less in November. And the first years there, it was kind of showing decrease. You can think this as an OC diagram as well. So it looked like the period was shorter than 1 year, and it was, for example, this point is 2015 was last day of August. And it was thought that maybe the next outbursts are in summertime. But then the next next outburst was next year on December, so it was very late, and even the monitoring program, there was an email that we have missed the eruption. That maybe it was in the summer, but suddenly it was there in December. And even the next one was even later in December 12th. And 2017 was November 6th, and my discovery was also on November 6th, so it was exactly 1 year between those two eruptions. And then it was it last day of October, and now it was November and December 2nd. So you can, I would say that it will explode in maybe November this year. Some message from Martin Hens. Maybe the last sentence here is important. He would like to encourage all interested amateur astronomers to participate in cutting-edge research to the best of their abilities. And the current PI, Matt Darnley from Liverpool University, he sent this message to me, maybe it was this week, when I was asking what is happening in the future. So he said that they definitely will continuing this monitoring program, and they have already a telescope time for this year's eruption, and he had submitted a proposal for Hubble Space Telescope observations as well. Just waiting for the someone to see the nova again. And the future campaigns will try to focus on the first 1.5 day of the eruption, because the light curve of the first 1.5 days, it has been different on different years. So it is unclear why this difference is, to understand what is going on early on. And I welcome everyone who has a large telescope, 30 centimeter, 40 centimeter or bigger, to join this monitoring. It doesn't take a lot of time to make one data point on beginning of each night. Then you can be the lucky one who discovers the next eruption. Okay, thank you.
Thank you very much. Do we have any questions for Arto?
Hello, Arto. I was
Hello.
just wondering, so every year since 2008, are there any discoveries before the date of eruptions afterwards, or was it
No,
never?
this star was discovered in 2008. No one was observing before that, and there was no previous discoveries. So I think no one was trying to find those nova outbursts in Messier, in the Andromeda galaxy before that. I don't know.
Only a minor question. Your script for photometric measurement is within MaxNDL?
No, it's a ACP script.
Ah,
Just then I get from that script I get 25 calibrated images, and then I just use Maxim DL to combine them. Just
you use
few clicks.
Maxim DL only for stacking? Use Maxim DL only for stacking?
Yeah, only to stack those images. Yes.
Why do you choose 60-second imaging, not 2-3 minutes?
Well, I didn't get it.
Why do you select to take 60-second images? As the signal is very slow and you are not low and you are not going very fast. So 2 minutes, 3-minute imaging would work as well.
I think it's just a habit. I'm doing almost all my observing with 60-second exposures. We have a good calibration, dark frames and everything on that 60-second exposures, and I haven't seen big difference if I take 2-minute exposures, maybe 10 2-minute exposures, and combine them and comparing with 25 1-minute exposures. It's about the same. And if there's some problem with some images, some satellite or whatever, or bad tracking or something, I can drop easily one 60-second exposure.
Yes, the question was, it's the source of the noise. If there is no moon, probably the big source of noise is the readout of the CCD. So if you have longer views, you have less noise, you have a better noise, signal-to-noise ratio.
Yeah, very marginally. I have done longer exposures. And it's also a question about tracking. The Paramount tracks very well, but not so well that with 2-minute exposure you get some trailing on some frames, and then of course that doesn't help stacking those images.
Do we have one final question? No, then let's thank Arto again. And then we come to the final presentation.